All right, so rotations are the third kind of transformation that we're learning. All right, so remind me again, translations, what's my key word there? They
translate. Slide.
They slide, okay? So they slide left and right, up and down. Reflections, what do? They flip. They flip over the x-axis or the y-axis. So translations slide, reflections flip, and rotations turn. Okay? All right, so the key word is not necessarily the word. Okay, rotations, yes, rotate, but they turn. They turn. Can somebody think of a real life object that rotates? It's a real life object. The earth, right? That's like big object. The earth rotates on an axis. Okay, in the solar system, Connor? A chair. Wait, a chair? Maybe musical chairs? A chair doesn't rotate. No. Chair doesn't rotate. Something that would rotate around a center point. Something that would turn around a center point.
This might be stupid, but a protractor.
Yeah, it has a center point. What about a wheel? That's probably the most obvious. Yeah, a clock. Okay, because we have a center point. All right, so a rotation has to have a center of rotation, something that it rotates around. All right, so that's where we get this rotation, meaning to turn, but it has to rotate around something, and that's what we call the center of rotation. So guess what? On the XY axis, this point is what we call the point of origin. So this would be like the y-axis, and this would be like the x-axis. Okay? I don't want to get too far ahead of myself, but there's only 3 different kinds of rotations because I'm rotating in these chunks. It's either 90 degrees, 180 degrees, or 270. Because if I turn all the way around, so if I start here and I turn all the way around, what kind of turn is that?
A 360.
A 360 degree turn, and I end up right where I started. So it would essentially be the same exact ordered pair. So we don't do a 360 degree rotation. We only do 90, 180, and 270. All right, you with me so far? 360 degrees, I'm not changing anything. Okay? All right, so let's look at this a little closer. We have a puzzle piece. Okay? This is the original puzzle piece up here. Point P is the center of rotation. Okay? And this is the original orientation. Okay? So you're going to look for some parts of this puzzle piece that you could kind of fix. All right? So what would be an easy part of the puzzle piece that you could look for in each one of the rotations? I say maybe the cutout. Maybe the cutout, right? Do you see how this one is a cutout on the puzzle piece? So let's look down here, okay? I'm going to show you how it's turning. You see how the cutout is facing down? Well, if it turns one time, now the cutout is facing on its side. Imagine if I just turned it counterclockwise, 90 degrees. You see how the cutout would then be on the side? All right? Look what happens if I turn it again. Now the cutout's on top. What happens if I turned it again? Now it's on the right. Okay? So you see how it's turning around the origin? Okay, so which one of these would be a 270 degree rotation? Well, this one's 90. That's not it. This one's 180 because I did 2, you could almost say 2 clicks. Okay? This one is 270 because I went 3 times. So the puzzle piece that matches is B. The puzzle piece that matches is B. You see that? Okay, but it's got to be rotating around something, and that was point P. All right, so it's important for you to understand, okay? This is what I need you to take away from this example. How something can rotate around a point. 90, 180, 270. It can go clockwise, which I kind of view clockwise as like frontwards, or counterclockwise as like backwards. Got it? Okay. All right, so sorry. So the answer is B on that one. All right, so now I'm going to have to look at a graph. I think you have 2 of these on your homework. All right, I am only concerned with the rotation. Okay, so some of these graphs are going to rotate and then translate, or rotate and then reflect. If you can figure out how it rotated, that's all I'm looking for. Okay, so let's look at the red figure to the blue figure. Okay, if I rotated the red figure to get, could I get to the blue figure? Could I get to it if I turned it? If I turned it? Okay, so if I turn it 1 click, it's going to be on its side, right? Okay, so let's just talk like clockwise. Okay, if I take this red figure and I turned it 90 degrees, it's going to be on its side. Does that match the blue figure? No. But what if I did it 1 more click? Okay, no. Okay, so 1 click, it's on its side. The next click, now the short side, it's on top. And does it match the blue figure?
Yes.
So it's 180 degrees. Okay, this is a rotation of 180 degrees. To get to the final location, I would have to slide it also. Do you guys agree? Like, if I rotated it 180 degrees, it's going to be up here. But then I would have to slide it. But again, that's something I'm not going to make you do. Just tell me it is a rotation of 180 degrees. Okay? What about number 2? Can you tell if it is a rotation? Could you tell, like, if it turned 90 or 180 or 270? No. Could you tell? No, you can't tell because it's a square. Like, if you rotate a square, it's going to look like a square, right? So it's not, there's no way that I can tell. Now, what could I tell here? What kind? Yes, a translation. And a translation, this is our lesson tomorrow. But a translation, you choose a point. Any point on the old figure and the new figure, and you would count. It has to be the same point. See how it's the top right on both? And then you would count. 1, 2, 3, 4 to the right, 1 down, and that would be my translation. All right, but this is not a rotation. There's no way you can tell if it's a rotation because the figure looks the same on each point of rotation. Does that make sense, Michael? Does that make sense? Rotations are the ones you have to use your imagination the most. Okay, you have to be able to visualize it. That's the challenge. All right, so rotating. All right, you guys did a good job on that. Now let's talk about your codes. Okay, you have to understand how to read this. If you don't understand how to read it, your code will do you no good. All right, so this is really important that you pay attention to this. You guys ready? You ready? There are 3 points of rotation: 90, 180, and 270. Okay? For 90 and 270, I can go either clockwise or counterclockwise. It matters. For 180, it does not matter because you're going the same distance no matter which direction you're going. Okay? Does that make sense? If you're going 180, and that's 2 clicks, no matter if you go right or left, you end up in the same point. Okay, so here's my rule. If I go counterclockwise, here's my ordered pair set, and I'm going to explain it in a minute. If I go 180, this is my rule. And if I go counterclockwise 270 or clockwise 90, this is my rule. I want you to look at the very first ordered pair in all 3 of these. Look at the very first ordered pair. Does it look the same in all 3?
Yes.
Okay, because this is what it stands for. It stands for whatever the original is. It doesn't matter. This stands for the original ordered pair. They might be positive numbers, they might be negative numbers. It's the original ordered pair. The second ordered pair tells you what you're supposed to be doing with the numbers. So if you see in the second ordered pair that the order is reversed, guess what you're going to do? You're going to flip them. Okay? If you see in the second ordered pair that one or both of them is negative, that means you're going to do the opposite sign of the original number. Okay? So on this first one, you see that they're flipped, and then you see that y is negative, right? That doesn't mean your y value is going to be negative. that means it's going to be the opposite sign of whatever it was in the original ordered pair. Okay? So, if I'm going these 2 degrees of rotation, counterclockwise 90 or clockwise 270, I'm going to flip them and do the opposite of my y value. Okay? Same thing goes with 180, except now I have a different rule. Look at 180. Am I flipping the order on 180? Am I flipping the order? Do you see them switched? No. All I see is that x and y are opposite. Guys, this is the easiest one, and this is one that you should have memorized by the time we test. Whatever the x was in the original, it's the opposite sign in your rotation. Whatever y was, now it's the opposite. That's it. And then on the last one, you would flip them and do the opposite of x. Okay? All right, so let's practice. I need to rotate these 4 points, and here's my instructions. 180 degrees about the origin. All right, so can anybody actually just look back up in your notes, and I want you to write down the code next to the instructions. Okay, this is going to help you learn what to do to the x and y values, to write down the code. Negative x and negative y. What does this tell me? It tells me whatever x was in the original, now it's the opposite sign on my rotation. Whatever y was, now it's the opposite sign. But I'm keeping it in the same order. Is that starting to make more sense to you? Okay, so now let's do j. Look at j. Negative 4, negative 4. So my rule says it's just going to be the opposite. 4, 4. Okay? If you hang in there with me, this is going to make sense. In first hour, they all pretty much got it by the end. Okay? So what about K? What about K? If it's 180 degrees, anybody know? Josh?
The negative 4 would be positive 4, and
Yep.
the 2 would be negative 2.
Perfect. Just switch the signs. That's it. So you see how, if you see 180 degrees, whatever the signs were in the original, you know you're doing the opposite signs, but you're not reversing the order. You're keeping the order the same. Okay? What about L? What about L, Connor?
Positive 1 and 0.
Yeah, 1, 0. You can't do it like a negative 0. Micah, what about the last one?
2 and 3.
Yes, it's 2 and 3. All right. Okay, now let's do it the next one. 90 degrees counterclockwise.
Negative y.
Okay, hold on. Okay, so I start with x, y. Okay, look back to your codes. 90 degrees clockwise, Nick. What is my second ordered pair?
Negative y. It's the opposite of y and x.
Yes, negative y and x. That means I flip the order and I do the opposite y value. Okay, so whatever the y value was in the original, now I'm going to do the opposite sign. And I flip the order. So for point P, it was 2. Now it's negative 2 and negative 3. Okay, I want you to try Q and R now. Flip them and do the opposite of Y. All right, what about Q? Can anybody tell me what the new Q is? Somebody different? Connor?
Negative 1 to 6.
Yes, negative 1, 6. Good job. What about R? Michael?
5 and negative 1.
5, negative 1. Awesome. Anybody else get those? Okay. All right, so that's rotating. Now let's do more than one, okay? So you're going to see this on quizzes and tests where you do one transformation and then you take those ordered pairs and you do another transformation. So here you're going to see rotations and then reflections, rotations and then translations, okay? So let's see what it looks like. You have, okay, I made a little mistake on point B down below. Make sure that's positive 1, not negative. Okay? Make sure that point B is positive 1 to match the original problem. Okay? Of positive 1 up there. Okay? So my first transformation is a rotation. of how much? Rotate what?
Y.
90 degrees clockwise. So look back at your code. 90 degrees clockwise takes an original ordered pair, and what do I do with it? Flip, and opposite of which value? Look at your codes, guys. You should be looking at your codes. Flip 90 degrees clockwise, and do the opposite of X. Okay, do you see that on your notes? Okay, so let's look at the ordered pairs. I need to reverse point A and do the opposite of X. That means that Y stays the same. So my Y value comes first and the opposite of X comes second. Did anybody do that before I did? Anybody do that? Okay, I want you to rotate B, C, and D. I'm going to walk around and check. Let's see, Mason, did you get the new point B?
Is it -3 and -1?
Yes, it is. -3 and -1. Very good. All right, Allie, did you get the new point C? Very good. -5 and -1. What about the new point D, Deasia? Yes, very good. All right, are you guys catching on? Are you catching on to what we're doing here? You see how the codes are really important? And if you know how to read the codes, then you'll know what to do. Eventually, you will have to have this code memorized, okay? But it won't be for this test. For the test, you'll have the codes, okay? Only for the rotations, though. The other ones you're going to have to know, all right? Okay, so now let's do example 5, the modeling real life. Okay, it says a carousel is represented in a coordinate plane with the center of the carousel at the origin, right? So a carousel rotates around that middle part, right? Right? Anybody ever ridden a carousel?
I have not.
You guys are looking at me. What?
I don't know.
Okay, stay awake. All right, so guys, all we're doing here, it says at the end of the ride, if you've ever ridden one, do you end up at the same exact spot? At the end of a ride? The answer is no, you don't. Okay, it just rotates for like 2 minutes and then it stops wherever it stops. So it says at the end of the ride, your positions have rotated, here we go, 270 degrees clockwise. So now you need your code. What are you doing to your original ordered pairs at 270 degrees clockwise? So hold on. We start at the XY. Every single person needs to fill in from the code. You need to write in on this problem how you're changing your ordered pairs according to the code. Write the code. Okay? If you can figure out the code, your chances are there that you can get it right. If you get the code wrong, you're going to get the whole problem wrong. Okay? So how am I changing the ordered pair? Flip them, and which one's the opposite?
X?
No. 270. It said clockwise, didn't it? Yeah. 270 clockwise, guys. That's the very first one. Flip them and do the opposite of Y. So guess what? If you thought you were supposed to flip them and do the opposite of X, guess what's going to happen to all your ordered pairs?
I get it wrong.
They're going to be wrong. Okay? They're not going to be right. And while I'm at it, if you get one right, shouldn't you get them all right? Right? Okay? So let's flip them. What is A prime now? What is B prime? What is C prime? And all this means is this is the image. What's the new location? All right? We have the code now. Now I want you to determine the new location for each one of these points. You can imagine each point is like one of the little animals that you sit on. Okay? What's the new point for each one of these locations? So if I flip point A and I do the opposite of Y, do the opposite of Y. It's kind of hard when they're the same number. You really have to look at it. Nick, what's it going to be?
4 and -4.
Yes, perfect. 4 and -4. Did you guys get that? 4 and -4. Make sure you fix it if you didn't get it. What about point B, Micah?
0, -3.
0 and negative 3. You can't do the opposite of 0, so it's just you flip them. All right, what about point C? What about point C, Mason?
2 and negative 1.
Awesome. 2, negative 1. What about point D? Anybody on point D? Anybody on point D? Connor?
3 negative 2.
3 and negative 2. Awesome. Okay, so we need to get the hang of reading the codes and knowing what to do with the ordered pairs depending on how it is rotating about the origin. If you understand that, that's everything you need to know for 2.3.